3 to the power of 2x equals 3 to the power of x minus 1 multiplied by 2 to the power of 4 plus x. Okay, so where did you start with this? Uh-huh.
Equals log 3x minus 1 multiplied by log 2, 4.
Not multiplied. So just do the same thing as I said before. Okay, just do the same thing as I said before. Don't pick and choose your logarithms. Just take logarithm of the left-hand side, logarithm of the right-hand side. In other words, log of the entirety of the left-hand side. Okay, so just do that first. So don't pick and choose your logarithms. All right. So have a look at that on the board then. Anything we could do here? Plus what?
3x minus 1 plus 1.
Okay, so in other words, you're separating this single logarithm into two separate ones because you've got log of, well, let's call that a, times by log of, let's say, well, you've got log of a times b. Okay, if you call that a and that b. So using your law of logarithms, if you know you're taking the log of two things multiplied together, that's the same as the log of two things added together. All right? So log of 3 to the power of x minus 1 plus log of 2 to the power of 4 plus x. Okay. Does that make sense? You're taking the log of two things multiplied together, same as a log of each thing, log of a plus log of b. Okay. So I'll write the log of 3 to the power of 2x on the left-hand side as well. What could we do now?
2x log 3.
Mm-hmm.
Equals x minus 1 log 3
Yep.
plus 4 plus x log 2.
Excellent, well done. So in other words, you are taking these powers, so the 2x, the x minus 1, the 4 plus x, and because it's the log of some base raised to some power, you can effectively just bring these powers out the front by the third law of logs. So that's where they end up down the front here.
Then 2x log 3.
Yep.
X log equals x log 3 minus log 3.
Yep.
Plus 4 log 2 plus x log 2.
Perfect. So in other words, in that case, you are literally just multiplying these brackets out. So you're taking the x multiplied by log 3 and the negative 1 multiplied by log 3, and the same over here, the 4 times log 2 and the x times log 2. Okay, now what?
2x log 3
Yep.
minus x log 3
Yep.
minus x log 2
Okay, equals?
equals log 3 plus log 4.
Is it negative?
4 log 2.
Not quite. I think it's negative log 3 plus 4 log 2. Or you can write it around the other way if you prefer. So 4 log 2 minus log of 3. So yeah, all you've done there is you've taken any term with an x in other words, this term, and this term. You've taken it all on the left-hand side. So there, there, and there. Then you're just left with that and that on the right-hand side. Okay, now what?
X log
Yep, so factorise an x out.
2 log 3
Yep.
minus log 3 minus log 2.
Perfect. So yeah, you've literally just noticed that every single term, so 4 log 2 minus log 3. Yeah, you've literally just noticed that on the left-hand side, look, you've got an x there, x there, x there. Let's factorise that x out. Good. All right. Now what?
4 log 2
Yep.
minus log 3
Yep.
divided by 2 log 3
Yep.
minus log 3
Yep.
minus log 2.
Excellent. So in other words, you just said, look, I want the x on its own. X is being multiplied by a number. It's a horrible number. It's got logarithms and stuff in. Still a number. Divide both sides by that, and you get the answer as, stick it on your calculator.
Four point
4.12. Excellent, well done. So again, okay, it looks big, it looks horrible, but all that's going on here, the reason what makes it big and horrible is the fact that you're doing a lot of algebra, okay? Really, once you're here, once you've used all your laws of logarithms, it is literally saying, well, look, I'm just treating anything with a log in, so log 3 or log 4 or log 2, I'm just treating that as a number, okay? And then it's just algebra from there on out. Good. Now, just like before, you could have also done this, you could have also simplified before you started. So if you notice, you've got 3 to the power 2x equals 3 to the power of x minus 1 times by 2 to the power 4 plus x. If you notice, you've got 3 to the power of something equals 3 to the power of something times by something else. So why not take that 3 to the power of x minus 1 and divide it on both sides? In other words, you get 3 to the power of 2x divided by 3 to the power of x minus 1 equals this, 2 to the power of 4 plus x. So I'm literally just taking this term here, dividing it, so then I've just got the base of 3 on the left-hand side. And of course, if I'm dividing two things with the same base, I should subtract the powers. So in other words, I get 3 to the power of, well, 2x take away x, take away 1. So 2x take away x minus 1. Just be careful of that negative there. Would you be happy you get 2x take away x, which is x, then you take away another negative 1, which is the same as adding 1. And then again, you can just take logarithms from there. In other words, you can just take log of 3 to the power of x plus 1 equals log of 2 to the power of 4 plus x. Bring the power down, so x plus 1, log of 3 equals 4 plus x, log of 2. And then again, you just expand it out and simplify, so you're basically at the same place you were there, okay? So again, you know, the rule of thumb is, if you're dealing with something like this, just take the logarithms of both sides, okay? So as long as the only thing that's happening is either dividing or timesing, you can take the logarithms of both sides. It may be easier, however, to kind of do your simplification first, so in other words, to get to this point first, and then take the logarithms if you want to deal with fewer terms. But this way is absolutely fine. It's purely a preference thing. Is that okay? Okay, perfect.